In this lesson, we'll be examining patterns that we call arithmetic sequences. The definition for an arithmetic sequence is a pattern of numbers that has a constant difference between terms. So in other words, you're increasing or decreasing by the exact same amount every time, kind of like a linear relationship. So we look at the first set of patterns here. We notice that they're arithmetic because the first one goes up by 7 each time. That would be this one here. The next one goes down by 4 each time, and those are arithmetic. These, on the other hand, are not arithmetic. This one seems to be dividing by 2. And a constant difference has to be adding or subtracting. And this one follows a pattern. It goes up by 1, and then up by 2, and then up by 3. So it is increasing, adding each time, but the difference isn't constant. It's constantly changing, in fact. So those would be considered non-arithmetic sequences. Our objective when dealing with arithmetic sequences is to define an equation. We call it the nth term, or general term, that can be used to figure out things about that sequence, whether it's the term at the end, terms in the middle, how many terms there are, things like that. We want to create an equation. Our equation is going to be in this format. un equals u1 plus n minus 1 times d. un stands for your term value. For instance, u3 would be term number 3. u31 would be the 31st term of the sequence. U number 1, by that definition, would be the first term. N is our number of terms, and D is our common difference. Just to point out for you when you're doing your homework from our textbook, instead of UN, our textbook uses TN. IB uses UN, so we're just getting the habit of using that letter. So try an example. We're going to state the general term, which is just another way of saying let's create ourselves an equation. That's what general term means for each arithmetic sequence, and then find U number 12. So let's give this a try. So our equation, un equals u1 plus n minus 1 times d. Well, un is part of the equation. That's the definition for any term of the sequence. It's made up of the first term, which is 2, plus n is our number of terms. Now we don't know how many number of terms we have. It's a never-ending sequence. So it's part of our equation. And d, our difference, is 3. Now notice I put in brackets to remind myself to multiply. We are going to multiply this and this, which gives us 3n minus 3. And our general term, when we collect like terms, is 3n minus 1. So there's our definition for this sequence. I could then use it to find u number 12. The 12th term is 3 times 12 minus 1. Everywhere I saw an n, I replaced it with 12. So without writing them all out, I can figure out that the 12th term is actually 35. You guys can try the next one. un equals a plus n minus 1 times 5. Oh, sorry, negative 5. It's going down this time. So 15 minus 5n plus 5 when we expand gives us 20 minus 5n. And now, notice I put them in different orders this time. It doesn't matter the order it goes in. The numbers are important. The signs are important. The order is not. If we want to find u number 12 this time, we can do that. 20 minus 5 times 12 will give us negative 40. It's okay to have negative numbers in just your sequence. It's just a pattern, right? I'm going to try one more. Fractional one this time. Okay, same thing. So un equals u1, the first term, plus n minus 1 times d, our difference. Now this one, a little bit trickier to figure out, but if you look at terms 2 and terms 3, you notice it's going up by 2/3 each time. And really, we could have written this first thing, number 1 here, as 3 over 3, and the last thing as 9 over 3, and it would make it a little bit easier to tell what our common difference is. So we're going to expand our bracket still. So 2/3 n minus 2/3. 1 minus 2/3 is 1/3. So 1/3 plus 2/3 n. U number 12 will be 1/3 plus 2/3 times 12. Or if you will, 24/3, which gives us 25/3. So we make ourselves an nth term, a general term, an equation to represent our pattern. Okay, we're going to do some problem solving, some thinking. So an arithmetic sequence can be defined by the general term. So here's our equation that defines it. Find the first 5 terms of the sequence. So we can work backwards now. So if I want to find first term, u number 1, that's made up of 12 plus 4 times 1. That gives me 16. U number 2, 12 plus 4 times 2. That gives me 20. Now, there's a constant pattern here, right? So I don't actually need the equation to figure out the rest of them. I just need to look at the difference between the first two. And it's 4. So U3 is, oops, this number there, 24. U number 4 will be 28. And U number 5 will be 32, our constant difference. If I want to skip all the way to 47, well, I can't just read out the whole pattern. That would be a waste of time. So 12 plus 4 times 47. That would be a lot faster, right? We should get 200 for that. Okay. The sequence contains the number 300. Which term is it? So this is one of the numbers in our pattern. It's going to go in for our UN. Okay. It's somewhere beyond term 47. We have to figure out which one it is. So we have this equation that now needs to be solved. So 300 minus 12 is 4n. So we have 288 is 4n, and n is 72. So we could say that U72 is 300, the 72nd term. Okay, the last term of the sequence is 864. How many terms are there? Well, it's basically the same question. It's saying, here's a term in the sequence, figure out what term number it is. So we can solve this. We'll bring the 12 over again. We'll get 852 equals 4n. And if we divide by 4, we'll get 213 and n. There's 213 terms in the sequence. And then we'll try E. So is 644 a member of the sequence? Well, if it is, we can figure out what term number it is. So the same kind of idea all over again. We're going to solve this. We'll get 632 is 4n. When I divide this, 632 divided by 4, I get 158. Well, the fact that it came out to a whole number tells me that yes, it is a member of the sequence. I would say yes. If it didn't come out to a whole number, it came out to a decimal, it's partway between terms of our sequence, then we'd say no, it's not a member. But the fact that it came out to a specific n value, a whole number, tells us yes, it's in the sequence. This page, yeah. Okay, more problem solving. 3 consecutive terms of an arithmetic sequence are 5, 2k, and k plus 7. Determine the value of k. So I didn't need to do a little thinking here, but what does the definition of an arithmetic sequence mean? It really means that there's a constant difference between the two and any consecutive terms. So really, the difference between 2k and 5, in other words, 2k minus 5, should equal the difference between k plus 7 and 2k. Think of this as u number 2 minus u1. And that should equal u number 3 minus u2, right? It's a constant difference all the time. Okay, so really that means I have an equation I can solve. I can put all the k's on one side, the numbers on the other. Negative 5 minus 7 equals k minus 2k minus 2k. I'll get negative 12, and I'll get negative 3k, and k has to be 4. But it's recognizing the idea of a constant difference. And it allows us to set up and solve equations. Let's try a little word problem here. Jeans Inc. When it first opened, employed 300 people. Each year, the number of employees has increased by 15. How many employees will there be in the 9th year? So the fact that we have a starting point, u number 1, and it's going up by 15 every year as a difference, tells me this is an arithmetic sequence. Well, if it's an arithmetic sequence, I can make an equation for it. Okay, we'll do the same thing, our general term that we've been doing. And we'll get 15n plus 285. So I want to figure out what's happening in the ninth year, and I'll just figure out what number u9 comes out to. So 15 times 9 plus 285. Put that into our calculator, and we should end up with 420. Oops, why is that not working? Sorry, pen wasn't working there for a second. 420. Right, and what year will the employee employ more than 400 people? That's like saying, where in the sequence does 500 fall? So let's put that in for a UN value. And we'll solve this. Okay, so 500 minus 285 is 15n. That gives me a 215 is 15n. Divide both sides by 15, and n comes out to 14.3. So that means it's partway between years, partway between terms. If we assume they can only hire at the beginning of the year, well, the 14th year would be too small because it won't have gotten to 500 yet. It'd be slightly below 500. So we're going to have to say we need to round up here. In the 15th year, they will employ at least, they're actually past 500. Okay, but when we come across a decimal, we're going to actually have to round them up all the time to solve the actual question, because we have a term that's partway between terms actually, and that's not possible. Okay, let's try one more thing. Find the general term for an arithmetic sequence if the second term is 18 and the 21st term is negative 20. So, two ways of approaching this kind of question. We can use some common sense, or we can use some mathematical solving. We'll look at both. Mathematical solving, I know that u number 2 is 18. I also know that u number 21 is negative 20. I can take these two things and make two separate equations. I can say that 18 equals u1 plus n, and is 2 minus 1 times d. And I can solve that, or simplify that. But that's as far as I can go with that thing. If we do the same thing for the other equation, and simplify that equation, I now have two equations. Oops, that's a little confusing there. I now have two equations with two variables. That means I can use old methods, in this case elimination, to solve this. If I take this equation and write underneath, I'll get 18 equals u1 plus d. Well, if I look at the u1s, I notice they're both the same. I notice they have the same sign. That tells me I can subtract. If I actually do the math, negative 20 minus 18 is negative 38 equals 19d. In other words, d is negative 2. Now if I go back to the beginning, I had this equation, 18 equals u1 plus d. But we just solved for d. d was negative 2. So in other words, u1 has to be 20. And if I know u1 and I know d, I can make myself an equation. Right? That's our whole idea here. un equals u1 plus n minus 1 times d. Expand our brackets, collect our like terms, and there's our equation. That's using the mathematical way. So as I said, we can also do a common sense way. So we take the same question, let's bring it down here so you can see it. And we can do this in a common sense way. So let's go back to the beginning. We knew that u number 2 was 18 and u21 is negative 20. Well, this is 19 terms. That's the difference between u2 and u21. And we've gone down from 18 to negative 20. So haven't we gone down 38? Right? 18 minus negative 20, that would be 38. If we've gone down 38, in 19 terms, we can figure out our difference by taking negative 38 and dividing it by 19. Oh, d is negative 2. And if I know that u number 2 was 18, the term before it, well, instead of going down to it, I have to go up to, right? So it's got to be 20. So using a little bit of common sense, I can come across the exact same things that I solve for, but in the mathematical way. And so I'm not really picky which one you want to use. If you like this idea of I can use some common sense to figure out what's happened, totally fine. Or you can solve for it using some algebra, using some elimination skills. Elimination comes in handy. We've done it with exponential functions. We can do it here with sequences and series. We will do it with lots of other things. So it's a good technique to have in your pocket, but you can also use some common sense here. Okay, that's the end of this lesson. Try the homework. In the first couple of questions, there's something about recursive. Don't worry about that. Just finding the general term, the UN thing. And remember, our book uses TN instead of UN, but they mean exactly the same thing.